Yesterday we had like an appetizer of sustainability with during the fireside chat. I don't know if you've been here yesterday. That we had the honor to have here to the president, Mr. Conde from the Portuguese Space Agency, and Mr. Cortés from the Spanish Space Agency. And of course, we talk a little bit about sustainability. It's impossible not to talk about that because it's a key issue in space operations. But today, we have the main course here with these panelists that I have the honor to introduce you now. And the first one is Beatriz Gallardo, over there. Is the SST Space Surveillance and Tracking User Engagement Manager at the European Union Agency for the Space Programme, USPA. Prior to this, she worked as project manager at the European Union Satellite Center on Space Situational Awareness. Before joining SATCEN, Beatriz worked as system engineer at the European Space Agency. Beatriz holds a master's degree in telecommunications engineering from the Universitat Politécnica de Catalunya and an MBA from the ESSEC Business and Marketing School. She's also alumni of the International Space University. Beatriz is a space passionate and STEM ambassador, so for EVA it's quite important that we will talk about that later. She launched an experiment in space in 2009 with ESA, and she's also an author of 2 space books for children. Whoa. So the next one is Andrea Vena, is the Chief Climate and Sustainability Officer of the European Space Agency. He has over 30 years of experience in the space sector, both in industrial and institutional areas. Graduated in electronic engineering with a master in telecommunication system, he started his career in Alenia Spazio, the space branch of Finmeccanica, today Leonardo. In 2000, Andrea started his career at ESA by joining the Strategic Directorate, and in June 1st, 2021, Andrea was appointed Chief Climate and Sustainable Officer to ensure that ESA and its programs contribute to the Paris Agreement on climate change and the European Green Deal. Welcome, Andrea, and thank you for being here. Maria Antonia, there on the right, and Ramos is currently serving as the head of Space Traffic Management Policy and Business Development and GMV. With a solid background in the space sector, dating back to 2000, and experience working both in public institutions and private companies, she has been deeply involved in addressing the critical issues of space debris and sustainable since 2016. Her work encompasses various aspects of space traffic management, and we are going to be talking about that today in this panel. And finally, Violeta Gandullo, here on my left, is a consultant and legal advisor on international space law, member of a space strategy working group for the Spanish space platform PAE, collaborating partner of the Spanish and International Space Team and the Space Team Andalusia for the EVA Association. She's part of my team. Gender Equality and Equality Commission representative of AEDAE, Spanish Association of Aeronautical Law. And she's also a Space Law University researcher in the Universidad Complutense de Madrid, a researcher and legal advisor for the Space Research Working Group of UNDEF-INDAE on cyber attacks and cybersecurity applied to space. Whoa. Yeah. Okay. So, well, I think I reserved 5 minutes to present all of them because they have that amazing CVs that, okay. Thank you all of you for accompanying me in this panel. And let's start with the first question. This question is a general question for the panelists. And that's it. What do you think are the main challenges and also the threats that need to be addressed to ensure space sustainability? And we are going to start with Mariam, please.
Thank you. So first of all, thank you for having me here. And then going to the topic, for me, the main challenges is the increase in the space population. And from this increase, all the other challenges are derived. And well, if we look into the population that we have, we can make two big groups. One is the debris, and the other one is the active satellites. And in the part of the debris, in some orbits, we have what it is called the Kessler effect. If you look into the report, the annual report that is published every year, you see that even if we don't launch any other object, the population will increase in the coming years just because of the collisions among the objects that are already up there. And this is a challenge by itself. Yeah? And then to address the sustainability, you need to characterize properly this population of debris. We need better tracking of the population. We need to decide what to do with these objects. Yeah? If we need to do active debris removal, if we need to do servicing of some of these objects in the very long term circular economy by recycling. So it's really a major challenge. And then in the other side of the population, so the active objects, I was checking it just before coming here in the space track, that is the public US catalog. As of today, we have more than 10,000 active satellites in orbit, and in total there are like 46,000 objects in total. When I started here in the space debris domain back in 2016, as Irene said, there was around 22K. So the population has doubled in just 8 years, and this is exponentially increasing. What I mean exponentially increasing, back in the 2016, you could check it twice a year, and it would be a number that is more or less the same. Now you have to check it every month, and it's increasing, steadily increasing. And this poses a very interesting challenge, that is the probability of collision or conjunction between active objects. So as of today, it's 22% of the population, but the trend is to have in 2030, like 75% of the population being active objects. And you have to coordinate. So if you have a conjunction with a debris, you can decide, depending on the risk, if you maneuver or not, but that's all. If you are having a conjunction with an active object, you need to coordinate. And as of today, this is done based on emails and telephone calls, what is not practical if you are going to have a population of several thousand of objects. And, well, you need to have this coordination, and you need to take the decision as late as possible, if you maneuver or not, because you want to minimize the number of maneuvers. Every time you maneuver, you are decreasing the lifetime of your asset, and this is a challenge for the sustainability. So this is, I think, the main message from my side. So the population itself and the relationship between of those objects that are flying.
Okay, thank you. That's we had like a vision of the global map of of what is surrounding our Earth, and it's incredible how the growth is going faster and faster. Beatriz, please.
So first, sorry. First of all, thank you very much for inviting me to participate in this panel today. It's a real pleasure to be here today. Maybe it sounds a bit repetitive because Marian already addressed the challenges that I want to explain to you, but I think that it's good to emphasize. For me, there are 4 main challenges. The first one is the space debris one. So currently, there are around 30,000 space debris orbiting the Earth. These space debris are of a size of bigger than 10 centimeters. So these space debris pose risk to our satellites. Satellites that are used for our space applications that we are using in our daily life. Applications like positioning, navigation, air observation. There are many, many applications that we are using. So this is the first challenge. The second one is, as Mariam mentioned as well, is the increase of actors and also the increase of satellites in orbit. So she mentioned that currently we have around 10,000 satellites, active satellites in orbit. And I'm pretty sure that we all have heard about the new mega constellations from SpaceX, Amazon, OneWeb. So I was checking as well some web pages, and it is estimated to exceed the 35,000 active satellites in the coming years. So this poses another risk of collision avoidance. And then the third risk is, or the third challenge is the regulatory framework. So as the number of satellites is increasing, we need somehow some norms, some standards that we need to follow in order to make space operations safe. And last, but I think that it's also very important, is the international cooperation. So space is a global common, and we all need to work together in order to make our operations safe and be conscious of the risk that we have nowadays with this increase of space satellites and debris. And this is everything.
Thank you, Beatriz. Andrea, your turn.
Yes, good afternoon, and again, it's my turn to thank you for having invited me to this forum and to this panel. I don't want to repeat anything about space debris, so this is one of the three main areas where space is dealing with sustainability, which means the capacity of preserving resources for the future generation. The other two areas are actually beyond the low Earth orbit, so what is space exploration? We are moving back to the moon in the next years, and maybe we are going to Mars. So it's very important that we preserve those, let's say, ecosystems. We are going to have an impact, as always, when we go somewhere, as we did in past times, we are going to have an impact. So we have to be sure, do not perturb too much those kind of environments. And there are other sustainability challenges in the exploration. So the use of resources that are very precious, that cannot be taken always from Earth. It's very costly and very time-consuming. So in situ resources, it's something that has to be explored. Circular economy, we were talking about that a few minutes ago. And we do not think about that, but waste management is a fundamental sustainability issue for the outer space. So how we manage all the kilograms of waste that is produced out there. We cannot just put it in a bin and then someone is taking care of it. Then there is the other area that is the biosphere, so our Earth and the atmosphere. Also there, we know that we have sustainability challenges, and space provides a lot of solutions for helping the fight against climate change. But not only that, space should take concrete steps to minimize its impact. It's an industry like many others. We were listening to the aviation sector before. So also space is taking major undertaking to reduce the environmental impact of its activities during the design, the production, the operation phase. And this is very important to preserve biodiversity, but also to reduce the impact on climate change. And last but not least, Irene, if you allow me, the atmosphere. It's sure that whatever we produce on Earth is going to the atmosphere in terms of greenhouse gases emission, but also crossing the atmosphere and burning materials during the re-entry and the launch is something that is producing elements, minerals, particles that are staying there and may have an impact on life on Earth. So we must be very careful also on that.
Mm-hmm. Thanks a lot. Yeah, it's quite interesting what you said about the waste management. Actually, I saw, I think yesterday, an announcement from NASA that they are looking for a project to know what to do with the waste when we go to the moon. So it's they are looking for a project to manage that. Yeah, exactly. Violeta, she's going to explain the regulatory framework or how important the laws are here in sustainability management.
Thank you. So thank you, Fitea, for holding this event, and thank you, Eva, for giving me the opportunity to be here with you. Yes, of course, from a legal perspective, the growing number of non-traditional players warrants a legal need of, if not revised, new measures so as to ensure a stronger space governance for the safety and sustainability for the future of the space ahead. So the space is not anymore a place just for wealthy nations. Back in the days, the former Soviet Union and the United States of America at the Cold War. Today, CEOs like Elon Musk, Jeff Bezos, or Richard Branson at the helm of companies such as Spaces, Starlink, Blue Origin, or Virgin Space have disrupted a market long dominated by defense contractors. And one thing is clear, is that the space have become a greater place and is now more congested, contested, and competitive than ever before. Regarding space law, international space law generally falls into two main categories. One is the so-called hard law. Those are the international conventions and the treaties, the so-called corpus juris espacialis, and the other one are the soft law. The soft law are the recommendations, guidelines, are non-normative, voluntarily guidelines that used to convey ideas or ideals on areas in which it's really difficult to achieve consensus on. So for those who has criticized the space treaty, the Magna Carta, in my humble opinion, is because this space treaty was created back in the days where only 2 states were capable of conducting space activities. But now, dozens of not only states but companies operate routinely on a daily basis. Also, because the space treaty was never intended to become an exhaustive framework. Subsequent treaties have been created and established so as to deal with specific problems, such as the Liability Convention or the Registration Convention of the objects launched into the outer space, or even the Rescue Agreement on astronauts and objects. So today, and I will later address the Kessler effect, the main problem from a legal perspective is that hard law and soft law has to be considered on equal footing, and they have to cooperate and be in coordination.
Thank you very much.
Welcome.
Violeta, let's continue with the next question. This one is for Andrea. And is why space environment has to be designed to preserve our life on the planet, monitoring climate change as the sample you mentioned before, the climate change. So if you can explain more about that.
Yes, I would start with a true fact that space is on a very hostile environment. So resources are scarce. We have to learn how to manage scarce resources, recycle, and inventing things. We have a laboratory up there since 20 years that is the International Space Station. We have learned a lot from this experience, and many of the technologies and processes that have been developed there are very useful these days where resources on Earth are scarce, and then we have to use those technologies. We can grow plants up there, we can recycle water, we can recycle even waste in some cases. Coming back to Earth and to climate change, for sure space is providing petabytes every day of information, of data about climate change, the wealth and the health of our planet. Climate variables are provided by space. 70% of them, the variables that are used to monitor the situation and the evolution of climate on the planet, are coming from space. But space is not only that. Space data can help the management of precious resources on Earth. And I used to make 3 examples. The first example is food. Food is going to become more and more difficult to be produced and to be grown on Earth due to climate change that is changing the climate zones and therefore reducing the capacity to grow crops in certain areas. Through satellites data, meteorological data, satellite communication, and positioning services, we can help farmers to adapt their crops to the place according to the evolution of the climate change. This is the first example. The second one is water. Water is another precious resource that is used also for food production, but also for industrial processes. So again, this case, through artificial intelligence, machine learning, and satellite data, we can build up very detailed maps and prediction of water availability in different areas. So to be sure that we provide this information to local communities to facilitate the installation of industrial sites or the management of water in critical periods. And this is the second example. The third one is about energy. Energy production may be on the grid, so you can access to the energy by the grid, but you can also install some local production and be autonomous off the grid, as it is called. And sometimes this is more advantageous than bringing electricity in a local remote community. Also in this case, through space, you can have a detailed map of the evolution in terms of needs of local communities and evaluate whether it is better to connect to the grid or to have off-grid energy production.
Amazing. This question is again for Violeta. And we are going to follow with the issue of the preserving life on the planet. And it's why it's so important the protection of dark and quiet skies.
Indeed, thank you very much, Irene. The protection on dark and quiet skies is really, really important, and I will explain you why in 3 minutes from a legal perspective.
Thank you for that.
Okay, so anyone that lives in a big city knows that the act of stepping outside and taking a look up in the sky leads to an unavoidable disappointment. Because you cannot longer see the stars, only the bigger ones or the ones that shines the most are the ones that can be seen. This that can be a human problem, it is indeed a legal problem because it seems to be converging two space activities. One are the activities of the large satellite constellations, and on the other one, but not only, traditional astronomical observation. And as I've mentioned before, the Magna Carta, the Space Treaty, is not an exhaustive legal framework. It does not establish a numerus clausus. It does not establish a list of the space activities, and it does not establish a hierarchy on which activities are the more important, or which one is the most important one. So it's never going to say that the space tourism is going to be less important than the exploration of the outer space. So bearing in mind this, these two activities, the large satellite constellations activities and the traditional astronomical observation, are both lawful, legitimate. They have hence to be considered on equal footing. They have to coordinate and achieve. They have to cooperate and achieve coordination. And they have the limits of the Article number 3 of the Magna Carta, which establishes not only the due regard, but it states that all the space activities have to be conducted bearing in mind or following what the international public law status, what the United Nations Declaration says, and what the treaty says, bearing in mind also the sustainable use, the precautionary principle, and the non-transboundary harm, which is stated under Article number 9, which is the due regard principle. So, back in 2019, the Scientific and Technical Committee of COPUOS established that maybe the deployment of the larger satellite constellations may constitute a really huge improvement on communications. But on the other hand, their large number, their sun-reflected luminosity, and the radio frequency emissions were creating and having a really negative impact, not only on the traditional astronomical observation, and not only what NASA stated in a public document 5 years ago on the performing of the traditional rights of the Native American tribes, also the right that any one of us has to own a pristine sky, and not only for cultural or aesthetic reasons, but for the biological impact that it has in ourselves. So this is it. So again, since 2019, both communities, the astronomers and the operators of satellites, they have agreed and they are achieving coordination, but regarding the soft law principles. So as to avoid this unintended effect, of course.
Thank you, Violeta, because I didn't know about that, or I didn't think about that. But it's true that anytime we watch outside our skies now, they are not so darker as used to be in the past.
No.
And it's something that you don't realize when you. So thanks for your explanation.
Thank you very much. It's really important. So the people here, we were talking about Teruel. Teruel is one of the few places here in Spain. Teruel también existe. Teruel is one of the few places here in Spain that still owns a dark sky. And it's so beautiful, but I insist, it's not only just because of, cultural reasons, because of your biological impact. So,
okay.
Thank you.
No, thanks to you, Violeta. Beatriz, please explain more in the European Union Space Surveillance and Tracking, where you work in SST. Which services has been deployed?
So thank you for the question, Irene, because this question allowed me to explain what is USST and what we provide. So USST stands for European Union Space Surveillance and Tracking. So it's the operational capability that we have at European level to survey and track space objects. So our main objective is to ensure space sustainability. And well, it's important to mention that USST, we are working, USPA is working together with 15 member states of the European Union. These member states confirm what it is called the USST partnership, and we provide three types of services. So the first one is the collision avoidance, that is provides the risk of collision between a spacecraft and between a spacecraft and a space debris. We currently protect more than 500 spacecraft because this service is open worldwide. So if you are a spacecraft owner or operator, you can register and you can receive our services. Then the second service is the re-entry analysis. So this service provides the risk assessment of uncontrolled re-entries into the Earth's atmosphere. It's open worldwide as well. It was previously open for European users, but now, since 2 weeks ago, it's open to international users. And if you are interested to receive this kind of notifications, you can register through the USST portal. And last service is the fragmentation service. And this service provides the detection and characterization of in-orbit fragmentations. So those are the three services, are free of charge. The first one is open international to spacecraft owners and operators. The re-entry and fragmentations are open to any citizen that is interested on these services. So you are invited to register.
That's good. So as a private person, you can register on the service
with a personal account. Yes.
Oh, that's good. That's good. Thank you for the information, Beatriz. And let's talk now about space traffic management. Marian, that sometimes when we were preparing this session, I told you there are some similarity with the airspace traffic management, because I'm a pilot, so I'm really interested about that. Can you explain us more?
Thank you for the question. It's a complicated and interesting one. So, and the first point that is complicated is because I don't think that we can talk today about space traffic management, because there is not even an international agreement on what is space traffic management. So Violeta was talking before about the soft law, the hard law, and so on. So as of today, we don't have a frame in which we can implement a space traffic management. So today what we are implementing is one step back, is the space traffic coordination. That is, to a certain extent, easier than space traffic management, because you can use these guidelines, this soft law, and you can progress solving or mitigating this challenge of the active versus active objects. So what do we do from the technical point of view to implement this space traffic coordination, especially taking into consideration how the population of active objects is increasing. And what we are implementing, or what is needed, is an automation of all the process. So to implement this coordination, you need to know when a conjunction is happening. And for that, you start with the observations using sensors on ground or in space, telescopes and radars. You need to compute all these measurements, then you build a catalog of the objects, then you compute in this catalog who is having a conjunction with whom, you assess the risk, and then you coordinate who should maneuver. In all this process, almost everything is automated, except for this last step in which you decide how to maneuver and who has to maneuver. And this is the step that is really where a better defined framework is needed, because you need some transparency in the operations. So, for example, we were talking before about the mega constellations. They are implementing automated collision avoidance. So you need to know what they are doing. Otherwise, you just stay like this and hope they are ducking you. Yeah, yeah. And this is not feasible or not practical. So you need transparency on how they are conducting these operations so that it can be implemented. And then, from the technical perspective, you can do many things. You can have multi-agent platforms in which all the stakeholders and actors can communicate together, having standards that are known by all of them. So there are many things that are being implemented and that are ongoing, and I hope in the next years it will be even more automated and easier for the operations.
Okay, yeah, we were talking like if we are like in the 50s of the air traffic management now with the space traffic management, more or less. No? Okay, thank you very much, Marian. And the next question is for Beatriz, and it's like a practical case that I don't know if you remember that 2 years ago, Spain closed airspace partially and delayed 300 flights as a Chinese rocket debris fell to Earth. Actually, I had to, I couldn't fly that day. I had a program flight and I couldn't fly for this reason. So, really interesting to know how in the SST, how did you manage this event from your department, Beatriz?
So I remember very well this re-entry because I was part of the task force, and with this I already advanced to you the answer of this question. So USST, when there is a high media interest event like this one, because the size of the object was, the weight was around 22 tons and the size was 30 meters long. So the probability of the risk of the object re-entering to the Earth was very high. So this is why these kind of events attract a lot of attention from the media. So in these cases, what we do at the USST level is to activate what we call the task force. So the task force is a group of experts from different fields. So we have an expert on sensors, service provision, and other experts that are specialized on data analysis, communication, and so on. So we sit together, we analyze the data that coming from the sensors of the USST network of sensors, and we somehow estimate when and where the object is going to re-enter. So with this information, we publish our products, and this is linked to the previous question that I asked you. If you are interested, you can register to receive this kind of information when an event happens. And so we, based on this information, on these products, in this case, EASA, the European Union Aviation Safety Agency, issue a safety bulletin just to inform the public about this expected re-entry. So in response to this bulletin, some national aviation authorities decided to close the air traffic. And in this specific case, it was included Spain because there were some overpasses over the south term of Europe airspace. So this is the story of this re-entry.
Yeah, and I remember on TV that when they were asking the people what they were not flying, it's like, they say there's a Chinese rocket coming to the Earth. No? 'Cause normally it's a maintenance problem or technical problem from the plane, but in this time it was like, no, it's a Chinese rocket, and the passengers, they were like, what? You know,
Very reassuring.
And it was a series of uncontrolled re-entries from these Chinese because they were building the space station and they sent these modules, the different modules, on a space rocket. And the space rocket was not designed to be reused or to re-enter the Earth in a controlled way. So this is why we are monitoring and the importance of having a USSD capability at providing this kind of information.
Thanks for that, because I was really curious about this, how all this was managed. Thank you, Beatriz. Next question is for Marian again. We are going back to the space traffic management, but now from a legal point of view.
Yep. So this is really linked to the previous one, and I've already gave some hints before. Yeah. So if we want to go to this automation of the coordination, there is a framework needed that would be these soft laws, the hard laws. From my point of view, what
This is
would
gonna
be
go after you, huh?
yeah, that's perfect. So from my point of view, what would be very useful is to have some sort of rules of the road for a space. Yeah? So some. As of today, this is like the Far West, so nobody knows who has to maneuver. You know, you come to an encounter and who moves, yes? So you start a coordination process. Well, I am in this phase of my operations, I am in this other, I have so much fuel. So there is some sort of conversation between the operations with the OSST in between in some cases. And then you have to decide who maneuver. It would be much easier if there is a guideline in which it is said, okay, the one that is older in orbit is the one that have the right of way, yeah? For example, yeah. I'm not saying this is the best one, yeah, but it's just an example of the many rules or many ideas that we can come with, yeah? And maybe you say, well, why we don't have it now? It's because until now it wasn't needed. So there weren't so many active satellites. So you can imagine when the traffic roads started, yeah? Maybe you have seen these pictures from Madrid in which you had a traffic agent there in a booth in the middle of a crossroad saying, you come, you stop, yeah? So you didn't have the need of these traffic lights and so on. So it was implemented when it was needed. And now in space we have this need urgently, and it has to be decided and agreed internationally. So for me, this is one of the things that is key for this automation of the operations. Then the other is the standards. In this case, I think we are much advanced. So these standards are to easy the communication between the operators. So we have the CCSDS, that is a standard of messages that are used for communication, and this is widely accepted internationally. So here, even Russia, China are using this standard. This makes things easier. And then the last point that I think is needed is some protocols and procedures that establish how you communicate. Yeah? So we have some examples from aviation, for example. Maybe you remember the accident in Los Rodeos, in which there was a misunderstanding, miscommunication between the plane and the control tower. And after that, start the phraseology, the standardized way of communicating. Yeah? So you use standard sentences to communicate at certain times and so on. So we can learn from that and have already these procedures and these protocols in place to avoid any kind of misunderstanding. So these are, for me, the 3 points, yeah? the rules of the road, the standards, and the protocols and procedures that are needed for the automation.
That's very interesting. I'm working in road safety, so thanks for the example that I think is very precise. No? When you need it is when you have to implement it. It's your turn to...
Yeah, okay. Antonia, if you think this is the Far West, wait for the space mining to arrive. Yeah. And it's already here. That is going to be the Far West. Okay, there's a framework regulation, okay? Yeah. But believe me, I cannot explain you responsibility and liability in 3 minutes. It's crazy, and you're not going to understand anything. So what I'm going to do, and partly I'm going to answer your question, is to tell you why I consider that a space debris is a space object, because it has legal implications, okay? So, of course, after 50 years of conducting space activities, those has brought technical and scientific improvements, but on the other hand has led to the creation of a space junk. But after 50 years of conducting space activities, we don't have still an international agreed definition of what space debris is. One possible definition could be any man-made object, non-functional, with no reasonable expectation of assuming or resuming its intended function or re-entering the Earth's atmospheres. This entails fragments and component parts, are also the Commission and derelict satellites, like the Chinese one, and also the spent of the upper stages of launchers too. So the Chinese satellite we consider a space debris, and it has a lot of implications. Because this may lead with some stretching and interpretation, because of course, the Magna Carta does not establish any answer regarding space debris because we didn't need it. We were trying to avoid a conflict like a Third World War conflict on outer space. That is why that is written in that way. But we can take the answers from the text. Okay, so bearing in mind this. What the Magna Carta says, the Space Treaty says, and the Article number 9, as I've mentioned, the due regard, it says that the state parties has to conduct their space activities with due interest, with due respect, with taking into account the interest of the rest of the state parties to the treaty. Okay, so this leads to avoid the creation of, to reduce and to remove space debris too. But of course, a space object that is capable to approach, to touch, to attach, and to remove space debris is capable of conducting space surveillance activities with much more aggressive intentions. Because also, and bearing this in mind, you have to take into account that what you need so as to remove and doing the docking and the removal of any space object, you require such adequate and so much information about that space object that may have a really negative impact on intellectual property, on confidentiality, and on many other regulations. So why is this, why I do consider that the space debris is a space object? Because under Article number 8, it says that once you launch a space object into the outer space, and a launching state is the state that launches, that procures the launching, the state from whose territorial facilities a space object is launched into the outer space, that state treaty retains ownership and control of that space object. And this is not being altered by their presence on outer space. Hence, you're going to be responsible if you cause any damage to any space object. Also, there is a difference, and I'm going to stop here. Because the liability convention is to fall depending on where this damage is caused. If it's caused that damage on the Earth's surface, the simple proof of causality is enough without proving fault. If you cause any damage or any space object, fragment, component part, cause any damage to any space object, their fragments and their component parts, you need to prove their liability. And the liability of the company for which the state is responsible on. Even it's more difficult because the liability presumes that a certain level, a certain standard of care exists regardless with the reasonableness of the infringement company can be judged. So it's really, really difficult. So How are we working today? With international space cooperation, guys. we have to help each other. Otherwise, there's no way. And of course, with the rules. And I'm going to stop here. Sorry. It's really, really complex.
Yeah, I understand that you could be talking about that for a complete session. Maybe we will think about that in the next PTA.
Thank you.
Because it's a very interesting area.
With much more
and
time.
very complex.
Yeah.
Yeah.
Yes.
Next question is for Andrea. And it's a bit thinking about the future. And we think in a few years or some years, we will have the station gateway orbiting our satellite, orbiting the moon. And that means that we are going to have, again, problems with sustainability in the moon. So what's your opinion about that? Is going to be gateway another, is an opportunity, challenge, another threat for sustainability?
But indeed, whenever we talk about the threats and risks, we are talking about opportunities because they generate opportunities to deal with them. I will refrain to talk back on space debris, but I would say that space debris removal and in-orbit servicing are representing huge opportunities, even though they are associated to risk. So the same will be in the so-called cislunar economy. So we are going to be there, and the amplitude of the endeavor is that in the next 10 years, we are going to have some 400 missions going to the moon, which is a huge amount of missions, considering that some part of them will be manned, so with people on board. Again, the challenges that may turn into opportunities are the ones that we were evocating before. So first of all is circularity. Whatever is associated to the reuse, to the reinvent, to the recycle, to the re-something, it's fundamental to make this sustainable. So it is a risk, because if we do not do that, but it's going to have consequences of sustainability, presence of mankind around the moon. The second one is about the resources. We were mentioning it. So resources cannot always be taken up there. It's not like the International Space Station that is 400 kilometers from here. The moon is far away. So in situ resources exploitations. And we work already on Earth to see how we can use materials that are available on the moon. For instance, the regolite that everybody knows is this powder that is covering the lunar surface, to make 3D printing. So potentially doing almost everything with that material, which could help us to avoid to bring things over there. And then again, waste management. I insist on that because the magic number is that one single astronaut is producing some 2,500 kilograms per year of waste. And this is very composite and different waste. Of course, there are human waste, and you can imagine what I am talking about. A part of it can be recycled. So actually, urine can be recycled, is recycled in the International Space Station. We are talking about packaging. There is a lot of packaging for food, for materials, for whatever. So packaging is something that has to be taken care of. And there is a huge potential for opportunities over there. And finally, the spacecraft itself, the way in which it is conceived, it is designed, it is produced, all these requires eco-design capabilities on Earth. So we have to think in a life cycle approach mindset, looking at what could be the reuse of a spacecraft, or what could be the reuse of those materials that once up there maybe are not any longer to be used for that first purpose. So all this is saying that a true complete economy can run across the cislunar adventure. Provided that this is remaining a cooperative adventure. As it is today, we know that it is a US-led initiative. There are countries that have already signed the so-called Artemis agreements. Now we have elections in the United States in few days now. And things may change, even though I don't believe so, because this is a very important thing for everybody in the world.
Okay. Well, last but not least, and Asvitea is mainly an educational forum. I would like for all the panelists to send a message for the students. And we're going to start with Violeta, because I want her to explain an activity she did this year that is quite interesting, that tell us more about the one and the only Children's Moon's Constitution.
Okay, but my advice to you is to please follow your dreams. What is going to set the difference between you and your colleagues is that you work in something you are passionate for. And now, regarding the, the Children's Moon Constitution, well, it just started with a conversation that Irene and I held, and it was just, I was supposed just to draft an article about women's equity on the moon's surface, okay? So I started drafting it, and suddenly it pops out. it pops up in my mind the idea of drafting the whole constitution, because it makes no sense drafting just one article. And while I was, sharing my ideas with the rest of the people that I used to like to work with and collaborate, they were joining in. So at the end of the day, it was the perfect example of international cooperation, because I used to collaborate with people of Latin, so my team were people, there were people from Ecuador, Colombia, Puerto Rico, no, but Argentina too. And here I would like to send my deepest thanks to the illustrator. Muchas gracias, Alejandra Romero from El Gato Ilustrado Ilustraciones, for being capable of illustrating the Constitution with such sensitivity. This girl had no idea of what the outer space was. So I had to coordinate a team that had no idea about space, and they were capable of, at the very end, thanks to International Space Cooperation, and bearing in mind the recommendations of the children of San Ignacio del Villar School, of balancing their ideals and aspirations and not useless constitution, but something that were a useful tool for them. So this is it. And it was thanks to Eva and thanks to Irene, and Sara Garcia was there too. So this is it.
Yeah, it was like an idea for a teacher from a village in Seville. And he asked me for support. And I said, I have the perfect person, to make the constitution with the children. And that's it.
But it was
and
very...
I think it's able to, we can, it's somewhere on the internet, we can
It's in the internet. Esther from Fly News told me that it was already at the web page.
Yes, it's in our web page in Ellas Vuelan Alto, if you want to look for it.
But it was very funny because she was asking me, why is that taking so long? Violeta, what are you doing? Just drafting one article. The whole constitution.
She did the complete constitution, the complete book, and
glossary.
But it was very nice thing, very nice.
If I may, this is the passion that you mentioned before. No? So if you work with passion,
I know Beatriz also. I think we talk with each other later. And Andrea, your message for the Artemis generation that they are listening to us now?
I would give you a few numbers. You know that the human Homo sapiens presence on Earth is dated 150,000 years. We spent a lot of time only in getting food. And we have focused on looking forward only during the last 150 years. So it's an eye blink with respect to the entire life of Homo sapiens on the Earth. This is to say that we have a huge potential in front of us. And STEM is at the core of this potential. Nobody can imagine where we are going to be in 50 years. I can dream about, but I think this is the very motivational pitch that I would give to you. So stay on STEM, don't forget your past, but stay on STEM because we need you for the future.
Thank you. Thank you. This is very inspirational. And Mariam, You're really committed with space sustainability. What's your message for those men and women that will continue to push the boundaries of space exploration so to greater depths?
I'm going to follow the thread that Andrea has opened. Yeah? So just keep on pushing the boundaries. So we are in a very sweet moment in space. We have talked about challenges, but I would rather talk about opportunities. Yeah? So to live and to grow. And I like to say that in space is where science fiction come true. Yeah? So you dream and you work for it, and then at the end you have it there, and you have what you have imagined. Yeah? And for me, it's really something very beautiful and very inspiring to dream about something and then see it coming true. Yeah? So just work on it, and it's a very good moment for doing it.
I think you are really lucky. The young
Yeah.
people now, you are in a very, very, very amazing moment. Beatriz, that you have written two books for children, talking about space, and you are also a STEM ambassador. What is your message for the student, especially for women, about that?
So I will try to be very brief as I see that we are out of, out of time. So my message to all of you is just choosing a STEM career is a great opportunity to shape your future. So find opportunities. There are many at European level. And as an example, at USPA we have traineeship programs where you can learn from space professionals. You can also grow your network professionally, I mean. Just to put my example, I was a young graduate trainee at TISA. I learned a lot from great professionals. I know people around the world. I've been working as a teaching associate at the International Space University, so don't be afraid to apply to any opportunity. I launched an experiment to space, so I'm a passionate, and my message to you is to follow your passions with confidence and be yourself. And the future is bright, is out of there, and is yours. So enjoy.
There's a
Okay.
space for everyone.
Okay, we have 3 minutes. So if some of you of the audience want to, we have time for one question,
Even two.
maybe two. No? Some of the students up there? Oh? No, no volunteer? Oh. Okay, so they are discussing. I think they want to ask something.
Hi, boys.
We are a bit pushy. Yeah?
A bit too much, no?
Otherwise, I will torture you with the liability coverage.
Okay, my colleague is asking about what are the career opportunities in EUSPA I'm specifically talking about the EUSST. Like, what are you looking for? Like, are those engineers? Are those scientists? Like mathematicians? I have because I have no idea how that works. It's the first time that I'm hearing about that, and
So first of all, thank you for your question regarding USP opportunities and on SST. So I think that we did not mention, but space is for everybody. So you don't need to have a technical background to work in space. So at GSST, we are looking for traineeships with profiles that can be technical, but also people working on the legal side. So we already have 3 trainees working with us. And if you are interested in all the opportunities that we have, you can visit the USPA website, and you can talk to me just after the meeting if you want. And I can explain to you better so all the opportunities that we have and the profiles that we are looking for.
if I may, Irene, just complement on what Beatrice was saying.
Yeah, sure.
If you have time this afternoon, I will talk about that. And the opportunities, as Beatrice was saying, are not only for STEM, even though in our agencies the large majority of jobs are related to scientific aspects, but there is room for everybody. And I invite you to follow my speech later on, and you will find what are the career opportunities at ESA, but at QSpace, pretty much the same.
So we have to finish now to be on time. Thank you very much to all the audience that you were sharing this panel with us, and thanks a lot to the panelists. Okay, let's go for lunch.
Thank you. Thank you, Irene.
Thank you. Thank you.